The Australian Curriculum Glossary defines place value as the value of a digit by its position in a number relative to its units place. Place value is first encountered in Stage 1 of the mathematics syllabus.
A decimal is a numeral in the decimal number system. The digits before the decimal point is the integer part, and the digits after a decimal point is a fractional part. Decimals are introduced as a concept explicitly in Fractions and Decimals 2, Stage 2.
Here, students begin to recognise that place value systems can be extended to tenths and hundredths. In Stage 3, this is further expanded to thousands.
The ACARA glossary states that the value of each place is 10 times the value of the place immediately to its right, and 1/10 of the value of the place to its left. Here is how you could view place value. Or, in scientific notation,
notice how the symmetry occurs around the units column and not the decimal point itself. Students often think that the decimal point is the line of symmetry. The misconception that arises from here is that the decimal point itself has a value and that there should be a 1th place in a number.
Amy McDonald in The Australian Mathematics Teacher suggests asking students appropriate questions to clarify this misconception. She emphasizes the importance of establishing the endless base 10 chain. This makes the placement of digits and their relationship to one another more important than the decimal point itself.
Another misconception often held by students is that decimals can only go up to 2 decimal places, that is, up to hundredths. This misconception arises because when students are first introduced to decimals in Stage 2, much of the content surrounds money, which only goes up to hundredths.
To overcome this, teachers may continue to use tactile materials that go beyond hundredths. Anne Broche suggests using a decimat to show how a whole can be divided into tenths, hundredths, and thousandths. The teacher should first model fractional thinking by shading a fraction and expressing this as a decimal. So 4/10 is equal to 0.4. 4/10 plus 5/1000 is equal to 0.405. This can then be utilised as a classroom resource for students to play in pairs. Another misconception is that the longer the decimal, the larger it is.
This misconception arises from a whole number understanding of the digits beyond the decimal point.
The 2005 article, Longer is Larger, or is it, suggests that the correct use of fractional language indicates a higher conceptual understanding of decimals. For teachers to clarify this misconception, they must reinforce the relationship between fractions and decimals. From Stage 2, students should be able to use place value to partition decimals up to 2 decimal places. This decimal is 2 plus 7/10 plus 5/100. This decimal is 2 plus 8/10. This partitioning provides a visual for students to move away from whole number thinking beyond the decimal point.